All right, yeah, welcome back to Cloud Computing and Big Data. We have our Prologue lecture 0 today, so sort of an informal lecture clarifying course content, clarifying lots of question and answers that, always be part of one of the initial parts of the course. My name is Morris. I'm around 20 years or more in cloud computing, high performance computing, big data, machine learning, deep learning. Lots of these buzzwords we will materialize in the course and also make the connections of all of them, which of course this course entails. You see also quite a lot of logos there because I'm a heavily researcher and funded by many research projects, and teaching here and there is of course an orthogonal activity. We come to these logos all over the time, maybe not necessarily all of them today, but we will see how they play a role in the course content as well. A lot. And also when we come to our industry project, something that you already have hopefully explored in some of the last, basically course hours last week for warm up, looked at the web pages, looked on the products they offer and so on. So let's see a little bit about the structure of the course. So this is something which is similar like the 2024 course. So I hope all of you have looked at this. Who has looked at the YouTube? Hopefully all of you have used the course hours. Good. So the course content will be very similar structured, but you can imagine elements like machine learning, deep learning, large language models evolve extremely fast, right? So there will be lots of updates orthogonal through all of these lectures. A couple of slides will always change. However, the whole idea of the course, the whole point of the course is very similar. You see there that we start basically with a cloud computing introduction. What is big data? What is cloud computing? You see also the different color coding, the blue versus the green. This has something to do with assignments and more practical topics. So the green ones are usually somehow related to assignments or the industry project, and I come to that also later in the lectures. But we start with a very interesting small machine learning introduction, which is, let's say, something which you don't need any prerequisites for, right? So I've seen the hands were not so many used in machine learning before. We will start with a very simple introduction into this, and then we'll use in clouds already, let's say, very simple learning models in this. The idea of putting this in the course is that it has a tremendous impact these days in computing, in cloud computing, as well as high performance computing, which is my second field, basically, that I also teach here at the university. Hence, it's very important to talk about. Suna, could you mute, please? Thank you. Oh, sorry for that. So coming back to the structure of the course, we basically then have a very crash course in machine learning. If you really want to know more about machine learning, you should have a proper course in machine learning. I mean, Stein and Hafstein, others here teach this as well, but we have that really practically applied. We come then quickly back to virtualization and scalable data center design, where you have some conceptual aspects, how, let's say, cloud computing is really working. And this stands largely for very, very large warehouse-like buildings where lots of computing racks are standing that you can easily manage and can easily access via your web browser, right? So this is the idea of cloud computing, but how that works is virtualization, how you make that scalable for so many people that all use Facebook or whatever. Who is using Facebook? Or should I ask who is not using Facebook? So, I mean, almost everyone is on social media these days, right? So this is fueled by cloud computing, and we will talk about why virtualization is a necessary ingredient to this. We then continue with deep learning. That is by far now the most, let's say, use of our high performance computing centers that fuel cloud computing data centers. So hence it's important to talk about this, but also here you don't need to know the deep down math. Like in other courses, when you start with machine learning, deep learning, you have lots of machine learning theory, statistical learning theory first. We will do this here more practically applied in the course, so don't worry. And you have seen it maybe one or the other also in the YouTube recording. We quickly hence come to some applications, which also then gives me the opportunity to introduce a new lecture in the course, the large language models. As I was asking you already in the beginning here at the warm-up, I guess every one of you or nearly everyone that, let's say, have used ChatGPT has already used one, right? So these ChatGPT and others, Mistral, these are really on vogue, and it's not the only story. We have generative AI, so it's not only about language, text, and so on. It can generate image, video, but also audio and so on. And we will have a full lecture on it, but connecting it, why cloud computing is necessary for it, right? Without cloud computing, LLMs would not exist. So this is a necessary ingredient. NVIDIA GPUs play all a big role in it. Things we teach more in the HPC course to the detail. Here we keep it as a small introduction in the cloud computing course. We then come to something we call a classic paradigm shift, which stands for something like MapReduce. I don't know if someone have heard MapReduce before. MapReduce, okay, some of you. Apache Spark, perchance. Spark is sort of the next evolution of Hadoop and Spark. We will talk about this then in connecting the docs, why it's different to high performance computing and lots of GPUs at scale that we need for large language model training, and why this is related to high throughput computing, right? So in this MapReduce, we are much more interested in throughput of data than, let's say, really number crunching. And we will make the point for it when we come to lecture 8. However, there are 3, let's say, paradigms in cloud computing that you should all know. Hence, after lots of practical steps here in the beginning of the course, that which basically connects us nicely to the industry project I will talk about, because there the idea is to use some deep learning in clouds and to use your elements you learn also with some of the companies. We will learn on Thursday, right? So on Thursday, I can already talk to you here. It will be not a lecture again. There will be 2 companies. Ingolve, we have 2 confirmed, 2 SMEs coming here, talking to you, presenting their ideas and so on. So this Greenfish and or Green and Gedratgöf, yeah. Okay, so we have several ones already prepared for you and asked. So basically, this will be a stepwise process. But I encourage you also to really start this industry project early. Hence, we took also many of these, let's say, more practical topics early. You see the green, instead of just starting with infrastructure as a service, platform as a service, software as a service, conceptual aspects, and then teaching you the basics. The idea is to use a course project not 3 days before the end of the course. So our experience is a little bit from the last years that students start very late with it and then come in really time pressure, Christmas problems and so on. Hence, we start here the industry project early, and we start on Thursday. And all of you have hopefully already, let's say, explored a little bit the websites, right, on the industry project. It's 50% of the course, hence very important. And that's why we have also no exam. And originally students were asking for a project, so we turned the exam into a project based on essentially your student feedback. However, these 3 conceptual topics are really necessary. You need to go out of a cloud computing to know what the IAAS stands for. Today, you see even inflation of terms. You have database as a service. You have everything as a service. We talk about this in these lectures. Then connecting the dots a bit, maybe with MapReduce and then Apache Spark again. Big data analytics is a term. I don't know if you've heard it. It's a bit different than analysis. It's a term where really technology matters a lot, and data mining, where we will have a couple of applications which are more recommender engines, but also something which is related to shopping baskets analysis, just to make the case of scalability, and basically also where you can use cloud computing again with big data. Then when we, let's say, shift the view a little bit to more advanced topics in cloud computing towards the end of the course, there are 2 more practical ones. Docker container management, and I've heard Kubernetes, Docker, okay, says to a few. This includes Aptainer, which is another container technology we talk about, much more in high performance computing use, but let's say can be complementary use with Docker files and so on. So this is how you manage really the cloud computing environment. If you are basically more or less in charge or want to use some ready to run applications, we call basically containerized applications. And that's what we will do in lecture 13. Lecture 14 then picks on one important part of machine learning called hyperparameter optimization, AutoML. It's a very advanced technique. Has someone used that? Not really. Okay, that is also a bit, important to have in this course because it needs heavily computing. But every machine learner needs it, basically. So the key is that you have this hyperparameters in machine learning. We will talk about this, the learning rate and lots of parameters that you pick, but not systematically. And when we do this with cloud computing and high performance computing across 1,000 GPUs, we can do this systematically. Hence, we tune these parameters in an optimal fashion and get much more accuracy out of the machine learning models and less error. from these machine learning models in most of the cases, not in all. But that's why it's also part of this course. It needs heavily computing. It's really related to also some of the cutting edge Amazon, web services that you have there, and other topics we will talk about with AutoGluon. Then OpenStack cloud operating system is again a little bit a change of the view. That is something like when your boss will ask you, can you provide a cloud in-house, right? So you basically started as a software engineer somewhere, and then your boss knocks on the door and said, I want an internal cloud, right? There's a public cloud, a private cloud, a hybrid cloud, all terms we will have in the introduction. And there, the OpenStack cloud operating system gives you the Lego pieces, the building blocks to build an in-house cloud, right? And this is something where you don't have to reinvent and redevelop the wheel. This has been already developed, is open source and available. And you see that many cloud offerings are based on OpenStack. Not the whole set, they pick the Lego pieces as they want in order to make that happening. And the epilogue is really just, we look together at job descriptions to see that the content of the course really matters for you in job applications and jobs around cloud computing, so that you see that the course really has now the right content. Here and there will be additional practical lectures. You will see also, basically in the YouTube course, we had last year, there's also 3.1 is a practical lecture on Azure or something like this. So this will, of course, continue, including also invited lectures from my PhD students, from my collaborators, and maybe even from industry. Right, so having said this, and we will have the second part of the course as a flight plan of today, to go into each of these lectures in a bit more depth, right? I gave you an overview glance now in the first part of the lecture, and just that you know a little bit what's coming. And let's us come a little bit to the course motivation. And in the second half of the course, I will take lecture by lecture and see then, how we do some details in this. So the motivation of the course is obviously a key that you see also represented in the logo big data. So big data is a term fueled, since a long time now with many different V's. They call it volume, veracity, variety, etc., etc. But the more big data is available, the more we can do with machine learning, with analysis of data, also in cloud computing and in high performance computing. And it stands not on itself. It has a large infrastructure around it. And this is what we build up in the course material that you see around it also in this diagram. You cannot just throw machine learning on a big pile of data and then get something out. You need the computing, you need the tool sets, you need a lot of, let's say, expertise and skill sets. However, all of this cutting edge material is part of the course that at least gets you right away started when you start with industry. And this includes really the right facet, not to be too theoretical on the one hand, but also having, let's say, a bit of practical impacts in really commercial cloud providers. As I said in the beginning, we look at Google, Amazon Web Services, and also MS Azure. These are the three, let's say, major cloud providers that you have around, but also, of course, there are a lot of them in the academic field or very specialized one that we will also look at. There's also one element, again, where we have one lecture, but it will be stretching here and there again to others, is the idea of large language models, again, what we will do with this as a very attractive new topic. Having done this, the learning outcomes is hopefully that you understand something about parallel processing. And this is by far something which is underlying the cloud computing concept, because many people at once will use a computer at the same time, right? We use the laptop as a web server with a website, but the services that you have in the cloud are used by many, many users in parallel at the same time. Hence, the whole course will leverage distributed computing, parallel processing, but it's abstracting from it. So when you basically have the HPC course, we do this much more low level, right? We program distributed computing and so on. In cloud computing, we take this in a 10,000 feet perspective and have basically the web browser as an interface. However, you will understand that underneath, really, from these cloud service offerings is a lot of computing, a lot of data happening. And with this, also, let's say, many automated approaches that we will reveal in the course, and cutting edge technologies like GPUs. Who have heard from GPUs for gaming? Who has heard from GPUs for science and cloud and machine learning? Good. Okay, it actually converged, and we will learn this in lecture 1 quite nicely these days, although there are different types of GPUs still. But we will see how that materializes in a later topic of the course. Oops. So just that you know a little bit about me, why I have the, let's say, honor to stand in front of you and perhaps also the right. I do these topics since 20 years. I have a PhD in this topic from the Karlsruhe Institute of Technology in Germany. And I'm around 20 years in the Jülich Supercomputing Center. This will appear again and again. It's a big, large research center in Germany. But I'm also 10 years professor here, and we have a joint collaboration, a mutual partnership, because we are basically just a national lab and not a university. So we team up with many universities internationally. And we have also the largest and biggest European supercomputer, right? Jupiter, which will be now basically opened in 2 weeks. And around it is something we call a Jupyter AI factory, which is almost like a cloud, right, in the academic sense. However, based on these activities, I did lots of research projects in the past. Some people may be familiar with CERN. I don't know, CERN, this HEP, High Energy Physics Center. Okay, I was there a little bit a while also in the context of computing, doing their middleware when we found the Higgs boson. So exciting time also in US. But I do still largely research projects here in Iceland, a lot with industry, also with Ingólfur here. He is on the left here, so shy. Some of you may know him from another course, but he works with me also in the whole industry projects we will talk about also on Thursday and reveal that a little bit here today. Just a bit about the Jülich Supercomputing Center in Germany. This is basically a national lab. As I said, in the middle of nowhere was a nuclear research facility. That's why is it in the middle of nowhere. But you see there a large hall where basically the first European exascale system will be deployed. And we have many cloud services around it, which are very analog, like the ones that you have in Amazon, MS Azure, and Google, right? So we have Jupyter Notebooks. Have you heard from Jupyter Notebooks, by chance? Good. If you use Google Collaboratory, for instance, it's very similar and based on the same technology. So these are things which we will reveal, and this gives us a little bit the infrastructure to play around here and there with assignments. University of Iceland, I perhaps don't have to say too much because you're already here sitting. That means there's some interest of you. Also, sake of experience, who is Erasmus Mundi student? We have always quite a fraction on this. Erasmus exchange program. Okay, a few, okay. Interesting. From US, someone? No. Sometimes we have even people from US because it's so close to the US, to Boston and so on, and much more cheaper to study here, apparently. Okay, so yeah, we have a large footprint in remote sensing. So that is maybe perhaps something to say also from our research. We publish a lot in remote sensing, and this also is related to lots of computing needs. So satellite images, analyzing this, I come back to this in a minute. So this is yeah, something which is related to our fact that Iceland has also a national competence center for HPC and AI, but it covers also cloud topics. And I'm the head of this one. And you see here lots of our research projects. I miss a bit the European Digital Innovation Hub. But for you, the takeaway message is we're really always at the cutting edge of computing, exploring what's happening. Exascale is in the moment our aim to really have the most computing power in Europe. We have also the idea with UPEX to have our own chips in Europe, right? The Reha chips and so on, so that we're a bit more independent from other providers outside Europe. And yeah, a couple of things which are relevant again for the course will be the Trust LM project. We look into this much more when we have the large language model lecture. But there's a large research project I have together with Hafstein Einarsson, an NLP professor here, natural language professor, also doing with me this research project. A new term which coming up is European AI factories. I'm not sure, have you heard from European AI factories by chance in the media? There's an amazing pot of money basically set free for AI in Europe to really help SMEs, to help the public sector adopt AI, but also know about the dangers of AI. For instance, we talked about ChatGPT, large language models. If you're in a hospital, you don't want to use that, right? To put all the medical data of your, kind of patients into the cloud and let them store somewhere to analyze it or to translate it. So there are also some issues about it we will talk about. But we will also talk about the AI factories, what services they build, because they are basically very cloud-like interfaces again. And finally, the European Open Science Cloud is more or less for researchers, but had also interesting, let's say, services for big data management, data sharing, things from a Dropbox Someone knows a Dropbox or OneDrive, probably you know all, and stuff like this, right? So these are similar services in the, let's say, academic fashion. There will be also several events from this community. The Icelandic HPC and cloud community is based on simulation and data labs that you hear. I'm basically in the healthcare lab, but we have several other ones as well. And we have huge industry collaborations ongoing. Hence, we have also now this link to this course that we do this 50% of the course in terms of, this industry projects. And we received lots of good testimonials, so they like to work with us. Also with students. So you see here lots of good feedback we got over the years. I mean, Ingo, we collected them bravely with many of them. There are probably a couple of them missing, but several of those names will also reappear in the list that you should check for your partner industry project, right? So, I mean, the slides will be shared. You can read the details on it, but in other words, this kind of course interaction with these will go back on a trusted relationship with our, let's say, close collaboration partners that like to work with us. And this is what we also would like to involve students more closer, basically, to industry. And you see here on the top right also the Canvas list, right, on some of the websites. That is something what we already provided, and you probably have seen already at Radgöf and others before in last week based in the preparation. Just an example how such a data lab or simulation data lab looks like. You see here an example of the remote sensing one. It's really strong. Our rector, or let's say the previous rector, was part of it. Jon Atle Benediktsson is basically one of the most distinguished experts in this field in Iceland. So, and we are basically also part of this group. Nowadays, also professors, interestingly enough. So Gabriel, you see there on the left, he was my first PhD. So now he's also professor here at the University of Iceland in the meantime. And this is by large fueled by high performance computing. We look at the satellite images when the satellite goes over the Earth, has lots of, let's say, we call that hyperspectral, multispectral data sets going into the Earth. So basically as a cube, right? So you see different spectrums of lights. And then we want, for instance, land cover to analyze, right? How much trees are there, how much water, and so on. And all basically remote sensed by the satellite. And then we use a lot of deep learning, machine learning, and cloud computing and high performance computing resources with it. So this will become as examples throughout the course again and again to make the case that we always look in our course more or less beyond one GPU, right? So I think that's a key message to take away, that we are not concerned about one laptop or so, that we have a big data center hall where we use multiple GPUs together to solve a problem. Now, usually what questions are is how is AI, ML, DL related, right? So machine learning, deep learning. One way of looking at it is that artificial intelligence is really huge, right? It's a field which entails robotics, cognitive systems, much more than this course entails. We always talk about AI, but when we have a concrete term, something, algorithms we really execute on the computer, we talk about machine learning, deep learning, right? So this is mostly real essence of it. And when you come to machine learning, it stands mostly for data, learning from data. There are distinguished algorithms that have been standing the test of time, support vector machines, random forests, and so on. So this is something what we still use. I will make a point why we still use them. And deep learning is now more or less a little bit a newer concept where you have also feature learning inside. So you have something which is much more interesting in terms of what you can actually learn from data in terms of automated approaches, what you get out of the data. So hence, they are not really in competition with each other. They rather complement each other. And we will talk about why in a moment. Just 10 sort of a recommendation why machine learning is necessary, right? So what are the prerequisites in a way? You see here the three. So that is always that there should be some pattern exists. That's why we go for machine learning and deep learning. And don't worry if you don't understand all of that in detail, right? We will have lecture 2, 3, much more on machine learning, deep learning, and then later deep learning again and again. So we will use that again and again, just as an appetizer for the course in the prologue. This is what we will talk about. The second ingredient is when we know that there's a pattern, we also know that there's maybe no physical formula for it, like weather prediction, right? This is something what we rather do with physical formulas. We know how it basically works. We have numerics and use that, although there are also some AHAAS these days that you can actually learn from data complementary. And the third ingredient is then that there are some data sets existing, and there should be, of course, reasonable large. And there have this overlap in a way, which we call today maybe data science, which is not only fueled by these different areas you maybe have heard from before. Also for the online audience, I should do this here with the pointer here. So this overlap I'm meaning here in the middle. And this data science is also fueled these days by heavily computing. So everyone who is using machine learning or deep learning with really cutting edge algorithms, with cutting edge approaches, usually needs also a computing infrastructure, right? Google Collaboratory is very quick at the end. But there are also several challenges around it. So machine learning is not the simplest topic. We have to learn a little bit of skill set around it. And of course, the data is not always so beautiful and nice, as we will see in lecture 2 and 3 when we go through some examples. But it is possible and largely successful and has led us nowadays to innovative deep learning techniques. So if you want a difference between deep learning and normal machine learning, you see this a little bit here, as I mentioned, that in previous times, we have really handcrafted features in order to learn a model from the data. So basically had some features, feature engineering done in order to learn a model. And deep learning now can have feature learning inside. How that looks like is now that we have some interesting deep learning architectures. So we will talk in some of the lectures about artificial neural networks. I think some of you have heard from that, probably, ANNs, artificial neural networks. So it's basically the basic technology of deep learning, where you have different neurons, you mimic the brain and have this. But a typical neural network would be seen here on this left side. But that's not what we do in deep learning. In deep learning, we just don't do more and more neurons and are happy with it. That's the base foundation. Instead, we have specific architectures that you see, for instance, here and very soon in the video, in order to capture the feature of images, for instance. Features could be noses, ears, eyes, for instance, of a human face. And this is automatically learned in all sorts of varieties, forms that you see here a little bit illustrated. And then you do at the end the classification if that is, let's say, a human, a cow, a cat, and so on. Hence, I wanted to just already materialize the start that deep learning is much more richer than just using artificial neural networks, like you see on the top left here, and put more and more neurons together. You have very specific architectures. And you see that a little bit here in the video.
It all begins from a single origin, a unique point in space and time.
We come now also to the point again of the computing footprint and the reasoning why we need still the combination of all of these, right? So we see traditional learning models like machine learning models we know from the past, support vector machines, random forests are very good models, but they only work when the data is reasonably small. Basically, when you have in big data, your laptop will already crunch with all the tools, right? So you need a bigger system. Then you maybe go to small neural networks. If you don't have a lot of data, then these models are still the best you can have, right? Because deep learning, what we will talk in the course, neural networks, deep learning models, autoencoders, and so on, they need lots of computing power, but also big data, hence the connection to the course, right? But the problem is you get much more accuracy out of these large deep learning models today than we have in the past from this random forest and whatever. But you have a big price to pay, which is the training time of these models requiring lots of computing power. Hence, this is all connected, these topics, and that's why we talk it about in the course. And of course, there's let's say another paradigm to it, which is not only the data we talked about and the hardware, where we have now GPUs, we have better computing power available. There's also the software. Nowadays, we have lots of open source software that makes it possible to have these packages like PyTorch, TensorFlow. Have you heard from PyTorch, TensorFlow by chance? So these are popular deep learning packages which are open source and also fueled a little bit this hype in deep learning that we have today. And with this also fueled the whole aspect of more development in hardware technology and so on. So there's a large, timeline coming back to the beginning of machine learning. And by having all these three ingredients now, you have lots of startups, lots of industries that we also will learn about that all want to adopt deep learning, basically then in our second part on Thursday. Just at the end of the first lecture, a couple of things that you also want to know about the course. I mean, this is pretty obvious. I guess by now almost all professors do the course in Canvas. So I guess all of you have seen it. There will be always announcement, assignments handed over it. Some of you contacted me already. The best chance is to do this via my assistant, which is basically Sika, that you can reach with this email address. She will be again and again coming up in the course. So I don't have chance to look at my emails anymore, but she will handle it and can also direct office hours, for instance, if you want. We have 3 assignments. There are 2 20%. One is a 10% warm-up, which is the 50% of the course in terms of grades. But also we have this industry project I mentioned before, 50% of the grade, which is very interactive, right? In order to do the assignments and also the industry project, it's good to build groups to 2 to 3 people. We come to this on Thursday, much more in the course hours. So maybe make yourself already, let's say, aware that you have 2 to 3 people you maybe want to work with, get to know each other, maybe after this course or in the break, because usually we want to have also group work encouraged, right? Alone work in industry is basically a no-go. You will always work in teams. You see the yellow blocks are essentially something you should take away from the course. They were mostly exam material. Now we don't have an exam, but of course I would encourage you to understand these yellow blocks that are really, let's say, the essence of the course elements that should be sticking to you in your head after this course. And all other things are again via Canvas. The assignment project upload will be mostly PDFs, sometimes source code upload via assignments. And yeah, this is nothing new, I would say. The only chance is that we don't have the ad tool for discussions. So we don't do the subscription anymore for some reason, but we will introduce some other tool. I know, Ingo, is there some other tool already in discussion? Yeah, so we will come to this, that we have, of course, also a discussion tool. This was a bit surprising. We used it a couple of years now. And everything else you already know from the recording. I mean, the recordings are online. 2024 is maybe the most up-to-date. 2022 is still on vogue. I mean, the most lectures will be still relatively serious. And you see, we got quite good feedback. That's why we do this also on YouTube. You see there on the top, not only the feedback from many people looking at it, we're using it also a lot in research projects to distribute our, let's say, research work and our activities and elements of this. So in this sense, there will be a new 2025 course list soon coming, and you can expect that each lecture will be recorded, right? If you don't make to the university, don't worry about this. Each lecture will be recorded. Not so in the industry ones and in the assignment ones. These will be internally recorded for Panopto, right? They will be only accessible in Canvas, so not on YouTube. I'm also heavily on social media because these days EU projects, European projects count more the followers and the likes than website hits. The websites are basically old and not so much important anymore. Hence, if you want, we can connect on social media. Some question about reading material. I would not suggest to buy a book in cloud computing. This will be outdated in a week. I have, however, some books I give you as references, and all lectures will have also significant lecture bibliography at the end, right? You have seen this already. Every now and then I have here references, and at the end of the course, you have like 3-4 pages really just of references. Finally, an appetizer, if you like the content of the course and want to go perhaps a little bit deeper, more technical. We have also next spring in 2026, the high performance computing course. This looks a bit more in parallel processing, MPI programming, again, machine learning, yes, also partly, but also much more physics applications. You see that here a little bit, like car crashes or computational fluid dynamics, smoke evolution, like here in a tube, and things like that, which are much more physical laws driven, or numerical methods based on known physical laws, I should say. This is all for now. I would say we stop the recording here. I give always video basically for you as a sort of homework. I will not play it now. I can do it during the break, but not for the YouTube recording. But I encourage you to look at it. So not only look my vision of cloud computing, but also a little bit connect what others think about the topic. So it's also a good resource to learn. So thanks. And we do a small break and continue with the second part then in 10 minutes.